GAC, what is up? This is Cyber Day Extravaganza. Hope you are doing well there. I guess here we go. We've got a live podcast right now. If you're coming online, I've combined the Algebra 3 and, Pre-Cal 12 and AP Stats. So what I'm going to do now is I'm going to start on the Pre-Cal 12. If you are watching this right now and you're in AP Stats, you can fast forward it to about 30 minutes after this time in this video. And if you show up at 10 o'clock, you should go straight to it and be able to go over the stuff that we need to. So again, Pre-Cal 12 we're starting with. AP Stats we'll look at 10 o'clock. So again, kind of fast forward that and putting all in one to be able to get some help there. So I have a viewer. Yes, I've got a viewer. We're going to get this rolling. Again, if you have questions, put them on the side over here, and we'll address as many as we possibly can as we get started on this beautiful, beautiful day today. Stay safe today, y'all. Hope all is well. And put some questions on the side. So before we do this, let's get this started. If you've got a question, throw them on the side here. I've got the live chat kind of over on the side so I could see it. So let's get this rolling. One of the things I did want to just address with you real quick is out on campus, if you go there, just be sure you follow it. I took off 4.6b. You don't have to actually do that homework. The only one you need to do is just the trig graphs practice is what I put online. So with the trig graphs practice, I would just kind of maybe get one of those there. We could focus on, I'm going to focus on level 3, but you need to do 2 of each of those levels. So just be sure you do that, and we'll go from there, okay? So let's get started. I'm going to throw this up here. Awesome. Throwing some out there. All right, I'm going to keep this on the side. Let's go over here. Man, yeah, it is. I'm messaging some people over here. It is kind of nice sleeping in today. A little bit different. What if we had a Cyber Day every day? Or once a week? How about that? I want to see y'all's beautiful faces. But for me, I could do once a week, right? Kind of cool. Do a little podcasting. I like it. No, don't mind it. All right, so let's throw this down again. If you watch the podcast that I did last night, it goes into more detail. I actually go through one of each of the levels. Like if you do one from each level, that gets you one. And then if you want to do a second one, we could even do you could do all 6 of them by watching both podcasts. So we'll go through as many as we can. And again, we'll stop at about 25, 30 minutes. For AP Stats. So just giving you a heads up on that part. But if you do have any questions, let's throw them out there. I'm going to try to, again, pull this up. There we are. Okay. All right. Yes. Some of you, yeah, we only got a couple people here, but again, we'll come to it. If you're in AP Stats right now, hold off. We're going to come back to that at 10 to 10:30. So we're going to do a little Pre-Cal 12. So just hold on to that. And we'll come to you at about 10 o'clock. All right. Okay. So, again, first thing I would do is start with the podcast, the first one. But if you're watching this first, that's fine. This is a lot of review with what we're looking at. Let's go over a few things we talked about. First thing, we talked about amplitude, didn't we? And with the amplitude, we focused our attention on graphing the amplitude first, meaning the number in front of that cosecant, in this case 1, we would put right there. So we have a amplitude, which is 1, right? We also then focus in our attention to our period, which is 2 pi over b. And we remember that in this example, we normally have A first, B second, C third. But the problem with this is the fact that the A is in front. The B is normally connected with X. But in this example, you'll notice that this is a little bit different. So because of the fact that the B is with X over here, it should go A's in front, B's with X, and then C is by itself, which again is a little bit different there. So, but that's okay. we're going to keep going. So the b in this case is -1. Now, you could put -1, but -2 pi and just regular 2 pi are both the same thing, okay? So we're just going to keep our 2 pi period. If we go in one direction or the other, doesn't necessarily matter. And remember, period is the distance I travel. This would be more of a sine graph, and remember the cosines, we start at the top. But nevertheless, 2 pi is our period. Our phase shift is c over b, and we remember that with c over b being the phase shift, c would be, in this case, pi, right? And b would be, total would be -1, okay? So we're going to put -1 in. So what does that mean? That means that when I plug this in, we would get a distance of -pi. But remember, we think of opposite. So we're not going to the left of pi because of the fact we think opposite of the signs with phase shift. I like what Chris said helps some of you out too. I know some of you like to just say, oh, it's negative, therefore we're going to move to the right on this. But it just in case, it's -c over b, and so really the sign changes. So my phase shift is positive pi. So what does that mean? Well, what that means is we're going to start at our phase shift, which is pi, okay? And that means that every time we move to the right 2 dashes, at least within my curve, we're going to have a pi that's added. So we're zeros at the beginning here. We go pi, 2 pi, and then the next one's 3 pi, right? You get the idea. The next one being, sorry, I'm doing this all by hand, so if it looks really messy, I apologize. Forgot it at work today or at school. For some reason, I didn't think that we were going to, thought there was no shot we were going to be off school today, but I was wrong. I was definitely wrong. So we just do it the scale by pi. So pi, 2 pi, 3 pi, 4 pi, 5 pi. If I were to do it again, I might spread it out a little bit more to give myself a little more room. But regardless, what we've got here is our starting point of pi to the right. And at this point, we're just going to see, okay, so if pi is our phase shift, which it is, we're going to travel 2 pi to the right. So we're going to go 2 pi from pi. So I'm going to go pi and another pi. And what this does is this gets me 3 pi. Okay, so my beginning is pi. I travel 2 pi. Remember, that doesn't necessarily mean my endpoint. It means the distance I travel, right? 2 pi means the distance from point A to point B, right? That is 2 pi distance, not 2 pi as my ending. So we've got pi as my start, 3 pi as my end, 2 pi in the middle. And then what I'm going to do is I'm just going to put these x's here, and you could probably figure out what we're going to do in this case. We know what is between pi and 2 pi. Someone probably said 1.5 pi, which true. Let's put it in as a fraction just right here. So this one is, and I'm going to put it up here so it doesn't get in our way of the graph because of just how I did it. But this top pot there, starting to get an accent, is 3 pi over 2. So that's our quarter point here. 2.5 pi, if you start getting confused with that, add the 2 together, 2 pi plus 3 pi. And what we could do is get 5 pi. And then we divide by 2 to get 5 pi over 2. So we'll just put 5 pi over 2 in as my next quarter point. And again, I'm going to put it up on top because if I don't, it's going to be really messy, and I don't have the pad to write on. So we're just going to keep it like this. So what we've got now is this thing is going to go from, again, cosecant. And again, I didn't even look at sine, cosine, or anything. I know that if it's sine, cosine, cosecant, secant, it follows the same pattern with what I just did. The only difference is once I go to sine, because cosecant and sine are linked, once I go to sine, I'm going to graph this by going straight through the first point. So it's going to go up, touch at the top, and then what happens is now I'm going to come back down. So this first part, again, it's always doing something at one of the 5 points. So in a sine graph, it'll go through the beginning, middle, and end. And in the quarters, it's going to hit the low in this case, and then the high in the other one. So that right there is one sine graph. If we were doing another one, we just, again, come here, quarters here. And again, if it does not look like balance, like where one's a lot larger than the other when you graph each period, you probably messed up somewhere. You might want to go back through and just check to make sure your scales are right or that you hit the right spots. But just be careful again. I've got to have one full period from pi to 3 pi. And remember that the distance from these two is 2 pi because of the fact that the period is 2 pi here, okay? Awesome. Well, I'm not seeing a lot of questions on this side. Maybe I think we have AP Stats that's waiting on me. But if you do have questions, throw it on the side. Hopefully, I'm just doing some more examples to help you out. The only thing that I would say is I'm not quite done. This right here was the sine graph. To find the cosecant, we would just go x on the x-intercepts, right? Wherever it hits the x-intercept, so boom, boom, right? The only difference between cosecant and sine is I'm just going to create these dotted lines, which are asymptotes there. Okay, I'm not going to write asymptotes down because we know what happened last time in class. We have one that goes up like this. Again, if it hits the highest point, just make sure it's between the asymptotes going up. And then this one is through the asymptotes going down. Okay, so there. And this one's going to go up here as well. Okay. And I hope that made sense to you. Probably should get another one here, right? And again, just showing that the only difference between cosecant and sine is just putting those dotted lines and making sure that the parabolas fall between the asymptotes. That's pretty much it on that side. Okay. All right. Man, we got a lot of people on this this side here. See a lot of good stuff coming to AP Stats in about 17 minutes. So again, if you're watching this thinking, where is AP Stats? Just fast forward and you'll see it there. You will definitely see it. All right, let's do a cotangent one because actually, did I not put another cotangent one? I think I did this one on the podcast. So let's do one from here. Let's see here. Okay, put this up. I'm going to do a one from level 2 here because, again, I did tell you, I mean, pretty much you could watch these 2 podcasts, get down the problems, and have most of them already done. So not trying to nail y'all, just trying to give you hopefully a way to prepare a little bit. So if you got other questions, throw them out there, and we'll go from there. I think I addressed this one on the podcast and the one prior to. So we're going to do this cotangent one. Y equals 3, I don't need to write it, but we'll do this. Y equals 3 cotangent of pi x over 2. Okay, so remember that when we have the cotangent, right, we have 2 things we find. We find amplitude and we find our asymptotes. Asymptotes, very good. Now, as loud as you can in your house, and if you're afraid of what people would say, you're at home. So just kind of, you got it. I want you to yell out right now as loud as you can, what are the asymptotes that we set cotangent equal to, or the traditional asymptotes there? Go. I hear you. I hear a lot of you. Very good. Nicely done. This right here, the O, always helps me out with this one because it tells me that with the asymptotes, I set cotangent equal to 0 and pi, whereas tangent would be pi over 2 and negative pi over 2. Now, with a cotangent graph, cotangents rise to the left and fall to the right. And tangent graphs, rise to the right and fall to the left. Okay? So this is tangent, this is cotangent. Now, if the 3 was negative, like right here in this example, this tangent's negative, the tangent that's negative on the outside will end up looking like a cotangent. So this one would also actually rise to the left and fall to the right. So as long as you remember that, you're Gucci, all right? Very good. I've got my coffee here. So just keep it rolling. So we've got cotangent. We're going to set pi over 2x. So pi over 2x equal to both of these, okay? So while I write these in, we're just literally just set them equal. And the goal on both of these is to figure out what the x value is equal to. So if we have pi over 2x, we're going to multiply by 2 over pi because that is the reciprocal, because that allows us to isolate x. But what we do to one side, we actually do to the other. And you'll know, and this should be pi, I'm sorry. Should be pi there. You'll understand that anything times 0 is 0. So we've got one asymptote that's at 0. And one asymptote, we're going to multiply by 2 over pi again on this side. This one's going to be a little bit different. These pi's are going to cancel, leaving me a value of 2, okay? So we got 2 here, we got 0 here. So what we've got is 0 on this side, and I'm just going to put 2 on this side, just to kind of spread it out a little bit. So we've got 2. This is my ending point. Makes it easy because the period and phase shift is already built into this. Okay, you don't have to solve for it. However, if I look between the values of 0 to 2, should make sense, okay? Between those two values, we have a period of 2, right? Because that's the distance I travel. So if I were to do another one, if I want another distance of 2, this right here would be a total of 4, right? Because again, if I add 2, I'm going to keep it consistent to be able to get that there. So I'm going to just kind of pull this back a little bit, erase that so it's not my way. So now we know in this case we have our middle, and we need to label our middle. Now this is easy. Between 0 and 2, that's 1. Between 2 and 4, that's 3. Other ones might be a little bit tougher, such as when you went to the sine and cosine ones. Remember how some of them were easy, some were tough. This one's one that's a little bit easier, but again, you might have to average them together, or some of you could see the pattern pretty well. But like if I didn't know what 3 was, I could add 2 plus 4 to get 6 and divide by 2. It's like averaging those values together. You get my middle value of 3. So we've got my two ones here with a cotangent graph. The amplitude we didn't talk about, but the amplitude is the number in front, just like with sine and cosine and cosecant and secant. So this is 3. Now, the tricky part of this is we know the graph's going to look like this, but to be a little more specific, instead of just going, oh, it's going up and this one's going down and oh, I'm done, we are a little bit more specific. At this X point, when I go up, I'm going to go up to 3. And when I hit this X point, it's going to go down 3. So this is going to go whoop, just like that. You do it at home, whoop, just like that. And there you are. There's your cotangent. So we're going to just mirror this over here. 3 down to the right and 3 up to the left. Just like so. Okay. Again, if it was negative, this would rise to the right and fall left, but we're good. We're good on that. Okay, let's see if I've got any other comments here. I gotcha. Nothing there. I want to see how many viewers. Oh, I've got 2 viewers coming. I think I lost one there. I must be boring. Must be. People must be frustrated. That's okay. All my Sweden followers, a little shout out to my Sweden followers. Thanks for showing up. And appreciate y'all for coming out today. Okay. My next part of this one, I'm going to do the, because I think I've done 3 total cotangent and tangent graphs. I want to finish off with one more. We'll do a secant graph because everyone knows we need some secant practice. So this will be my last one here to wrap up the 3 total for this section, okay? Just a heads up, since you're on the podcast, there are going to be a lot of ones like this. So y equals, sorry, I know it's really bad. I'm trying to do it by hand. Cosine of like 2x plus pi. That would be a really good one to do as well if you're like, man, I'm struggling on that. Tomorrow in class, Lord willing, if we have it, we're going to go over these 2 just as a practice before. But be ready to go with the quiz. We'll have some practice. We can kind of go over parts of this, but we won't have the full time to really go in depth. So come in the morning and get some help if need be, okay? All right, so let's talk about this one here, this secant graph. This one, secant, we obviously look at cosine, right? And the amplitude for this is in front, which is 1/2. I'm going to hop down to period. Period is 2 pi over b. The b is the value connected with x, and since it's connected with 2, we have 2 pi over 2 to get me a period of pi, okay? So we got pi as my period, or the distance I travel. 1/2 is my amplitude. And to get my phase shift, I'm going to do c over b, okay? C over b. Since there is no c on this outside, we know that that would be 0 over like 2, right? Because 2 is my b. But 0 over anything is 0. So my phase shift would be a value of 0 here, Okay, so we'll start. Again, my phase shift is the line of scrimmage or starting line or whatever you want to see it there. That's where I start, okay? Now, the period is the distance I travel. So if I were to do this here, I would say, okay, 0's here. And pi, I'm going to make it, again, this is my ending point, right? So I'm going to go about right here. This would be a distance of pi, okay? The middle between 0 and pi, you probably could see it. It's going to be 1/2, right? What's between 0 and 1? It'd be 1/2. And so this is just no different. We just include a pi that's there, okay? All right, so we've got that on that side. Now let's put a little x for our quarter point here and here. So what's between 0 and 1? Well, between 0 and 1 is 1/2. But what's between 0 and 1/2? That's going to be 1/4. So I'm going to put pi over 4 and go from there. Now, I want to put this on the podcast because I really like this. Chris showed me this. I think Mr. Washington had given this to him at some point. And as a teacher, you're always learning new things to teach it. And I do like this. If you know my method, continue to do it that way. That's absolutely fine. But how Chris did it is this. If I take my period length, okay, first of all, start at your phase shift. That does not change, okay? So that's still the same. But take your period pi and divide by 4. So if I took pi and divided by 4, I start at my phase shift, which was at 0. And then I just add whatever the period is divided by 4. So, and then that's the quarter point. So 0 plus pi over 4 is pi over 4, plus pi over 4 is pi over 2, pi over 3, pi over 4, and pi. So if I kept going with this method right now, actually, let me do this. Let me start with this. Let me graph this, and then we'll go to the second one, okay? So there should be one period between 0 and pi. So with cosine, because of the fact that it's secant down here, we're going to graph cosine. The only difference, since it's positive, is we start at the top. So we'll start at the top. We'll come through the x, a little bit different than sine, right? Remember, where I start is where I'm going to end up for this period, right? So sometimes that may help you. So this is going to go, it's kind of a mirror image of each other on either side. Hit the bottom. And there we are. So that is one period of cosine. Now, some of you on your homeworks forgot to do 2 periods, and I gave it to you. Just be very careful on the actual test, okay? Just be very careful, because again, we want 2 periods. So we again, what we could do is just, some of you like to, once I graph it, just kind of follow the same pattern and just go, okay, about every 1.5, we're gonna have an x or a period. It's gonna kind of go up and then hit the top here. One other thing is, because this is pi distance from here to here, if I added another pi, this would be another period. Therefore, this would be 2 pi. You don't have to get the x's here, though if you did, you could just add by pi over 4 each time. But between pi and 2 pi is, I think we did on the previous one, is 3 pi over 2. So the only thing I need to do from this point is create the secant graph. And to do that, I can just go down through the x-intercepts. And again, that's where the x's are, so that makes it a little easier. And once I do that, if it's right here, this would be like a half parabola, right? Because it could continue and go up. If you put a full one, that's fine. I think someone had asked that in class, which is perfect. So I go down here, this goes up here, and this is it. Going down right here and going up. And you can put the other one on this side as well. So that's what we would do for a secant graph. The only other thing that I would say is I didn't put the amplitude. So 1/2 would be here. Negative 1/2 would be the place where it hits right here, right? Make sure it goes all the way to the amplitude. The only other thing I wanted to address before I go to AP Stat is if I had a plus, this is not in the parentheses, so really the parentheses would be here. That +1 would affect, and by the way, you could put it 1 plus this or on the outside, same thing. That means that this would go up 1. So it would be 3 over 2 if I did that. And then this would go up 1, okay, which would be negative 1/2 plus 1, which is positive 1/2. So just a heads up on this side. Hopefully that makes sense for you, and go from there. No other questions. I don't think there are. Again, I'll post this podcast if you have any questions. At this time, we will transition to AP Stats. So again, I'm going to just send out a quick reminder, so hold on tight. Throw out questions while I do this, while I send this stuff out. But 10 o'clock, we're going to hit that. So give me about 2 minutes. AP Stats coming to you live on the same podcast. So if you're confused right now, we are transitioning to now some AP Stats stuff. Okay, so I'm going to go to some of the notes, and we're also going to hit some of the multiple choice sections. So give me just a bit here, and I'll be with you. All right, so hold on tight. I'll be right there. And you could throw out some questions there while I throw out this reminder. Just throw out the reminder real quick. Okay, throw this out to AP Stat. Again, and by the way, just a heads up, if you're wanting me to have a little bit more, let's say, need some more questions, we can stay a little longer than 10:30. So just a heads up. About 2 minutes. So I'm just throwing that up there in case you're not watching this live. You could just kind of check that out there. So just again, a reminder, hopefully, on that. Thank you all again for showing up. I see a couple people that are already ready to go. Make sure we got that. Perfect. All right, that is ready. The only other thing I want to do is get the multiple choice. So hold up just a second. And we're going to get the multiple choice section here. And we're going to start with that. But if you do have any other specific questions over the podcast in Chapter 3 that I addressed, please make sure to throw that out there to us, because I know there may be some questions on that. And if so, I want to make sure I go through those with you, okay? All right. I think it's on page 161, I believe. 160, is it 161? I just want to kind of put them up there so you could see them. All right, so we're going to go in here. All right, let's go. Yeah, I think it's at the back here. One of the things that I heard a lot of people say is just, hey, can we get some more practice on multiple choice questions? You know, what are they asking and that sort of thing. So this is a good way of trying to do it, is just kind of going through some of the example problems here. I believe this is on your homework. However, I don't think it's until later on this one. So again, just a heads up on that. Again, just a heads up going forward. Okay. So again, I'm going to get just a quick snapshots here, and then we'll get started here. Again, thank you for showing up. If you're with AP Stats, we're going to go through this here in just a bit, and we'll rock and roll. How about this? I'm going to actually post this. Yeah, let's take a look at this one. Okay. Yeah, this is good. This is good. I'm going to come back from this, and if you do have any other questions, I'm going to keep the questions off to the side here, and yeah, here we go. If you got questions on it, let's get them rocking and rolling. And without further ado, let's get going with the. Oh, hey, what's up? Good to see y'all. Let's get going with this. Okay, so this is, by the way, this is fresh for me, which would be kind of cool, a little bit of a challenge. What we're trying to do is just trying to determine what the multiple choice questions or the answers would be. The ones that are in red, you can kind of see that they have the answers there. We're going to go through as many of these as we possibly can. And so we'll address that and kind of go from there, okay? Awesome. I've got tons of people here today with the AP Stats 2 viewers. Here we go. All right, so here's what we've got to start us off. The question number 1 states this. You have a data set, and I'm doing number 27 right here, and I'll kind of blow that up. There we are. You have a data set for many years on the average price of barrel for oil and the average retail price of a gallon of unleaded regular gasoline. If you want to see how well the price of oil predicts the price of gas, then you should make a scatter plot with blank as the explanatory variable. Okay, so remember, explanatory means that it's on the x-axis, right? We talked about the x being the fact that it's explanatory, right? The x, explanatory, and it explains what the response is. So the response is on the y. We talked about that in class, and we also said that if we're trying to have something predict the other, then that means that the scatter plot with blank as the explanatory, I think this would be the price of oil is the part that explains or predicts the response of the price of gas, right? Price of gas doesn't have price of oil, but price of oil is explanatory to the price of gas. So I'm guessing the answer should be A. Yeah, that's exactly right. Okay, exactly right. Okay, let's go to second one, number 28. And again, I'm gonna keep the keep this on the side. If you have questions, maybe you're like, didn't get that one. Let me know, and we can walk through those together. Number 28 says, in a scatter plot of the average price of barrel of oil and the average retail price of a gallon of gas, you expect to see. Ooh, this is good. In a scatter plot of the average price of a barrel of oil and the average retail price of a gallon of gas, you expect to see what? Well, tell you what, let's look at this here. Actually, did I just close out of that? Let me see here. I think I did. Here, let me look at this here. I think I just closed out of it. I'm going to throw this up there, and I'm going to come back to not that. I'm going to go here. So as I looked at that, and again, you could kind of backtrack on what I just did. I'm sorry, my fault. I actually completely messed up, just closed right out of it. So one of the things that we could do in this example is try to just kind of throw up a scatter plot, right? Again, just like we did previously, does the oil predict, right, the average price of oil predict the average price of gas? Well, we're going to see here, and again, it doesn't really give you a whole lot of information, which kind of stinks, I know. But what it does give is it does give you the actual context of the problem we're looking at, okay? I'm actually going down, I'm sorry. All right, so I'm going to make sure I could see what's going on. Perfect. So 28, average price of barrel of oil and the average retail price of gallon of gas. So just like with 27, what we're going to do is we're just going to draw something here, okay? Where this is the oil, right, the explanatory, and it predicts what the gas would be, okay? Now the question is and this is the money, and I would put per barrel of oil, and this is the money. I'm doing this all by hand, sorry, y'all. Money right here. Money per barrel of gas. So as the oil increases, right, the barrel of oil increases, we know that oil is a part of gas, right? And it's the explanatory in this case to the barrel amount for gas. So if this goes up, what's going to happen with gas? We could intend for the gas to go up. So I'm guessing that as we go up here, it's also going to go up on this side. Now, how high? I don't know, because I'm not an oil expert or a gas expert. But we know it's going up. But if the oil goes down, right? Like let's say they found oil in wherever, fill in the blank, around the US. That means that in this spot, the oil would go down. Therefore, the gas prices would go down as well because oil makes gas, obviously. So we could expect a scatter plot. Maybe there is one that's out here, but we could expect a pretty we could expect a pretty strong relationship to when this goes up, this will go up as well. So let's talk about this, coming back to the question here. The question was, what type of association could we expect? Well, the little association is not correct. A weak negative association means that we would have, it would be going down to the right because it's negative. It would be a negative. And a weak means that there is one, but it's kind of a weak one, right? A strong negative is where it's really tight, right? It kind of looks like a line. They're close together. That's a strong negative association, but it's still a negative one, meaning if the average barrel price increases of oil, it should be expected that the gas oil price or gas barrel price would increase as well. And so I would say that there is a strong positive correlation between the oil barrel. As that increases, it will also increase the barrel price of gas. Okay. Again, had to think through that a little bit. That's there. Okay. Is it still stuck, y'all? It's stuck. Oh no. Did it stick here? Oh no. Okay. It's not continuing, is it? Is it continuing, y'all? Okay, perfect. Did y'all, Hannah, did you get that by chance? Did you get that? Could someone who's watching this right now, could you just did you hear what I just said with 27 and 28? I want to make sure before I continue. Hopefully that helps. I apologize for that. I don't know what happened. The only thing that I would say is maybe the storms could be affecting maybe the internet. So just giving you a heads up on that. It could be affecting your side. It could be affecting my side. So I just want to make sure. So if you did not hear that, let me know. Perfect. Okay. Now let's continue on 29. Number 29 says the following graph plots the gas mileage of various cars from the same model year versus the weight of these cars in thousands of pounds, right? So the weight, being the explanatory because it's on the X, explains the response of miles per gallon, right? So we're saying as the weight of the car increases, the miles per gallon decreases. So this is right here, we can expect this to be a negative association, and you could probably say a moderately negative association, right? So a linear association. So it's kind of going down there. But then it asks this, from this plot, we may conclude that there's a positive association between weight and gas mileage. Meaning, if it was positive, that means the weight increases, therefore the miles per gallons increase. And this would follow a general pattern of what I just did with my cursor there. Go across this way. And it doesn't, so A gets thrown out, okay? B says the correlation between weight and gas mileage for all the cars is close to 1. Well, we kind of talked about correlation in the podcast yesterday. In fact, we did big time. And a 1 correlation means a positive correlation, but that would be a perfect line, meaning each of the dots would form a perfect line. This is not a perfect line, correct? We know that because as we look at it, and also it's not positive either. So it's positive and it's not a perfect line. So because it's not positive and it's not a perfect line, we can't have a correlation of 1, so that gets thrown out. The next one said there's a little difference between Japanese cars and cars made in other countries. Well, we didn't even talk about cars made in other countries. We're just talking about cars made in Japan. So that has nothing to do with this because the weight and the miles per gallon are the things that are being associated. C has no relevance to the problem, and sometimes they'll do that to try to trick you. D, Japanese cars tend to be lighter in weight than other cars. Well, not necessarily, right? As we look at this one, we'll start looking and seeing that actually, well, are they lighter in weight than other cars? Let's actually look at this. want to make sure I look at the text. It says the following graph plots the gas mileage of various cars from the same model year versus the. Oh, hold up, my fault. I didn't even see the red ones. It says the points marked with red dots correspond to cars made in Japan. Okay, so the red ones actually come back to C because it does compare. That's my fault. I just didn't even read the question, which is definite no. But the red ones are the ones in Japan, whereas the darker ones, the purple ones, are the ones that are. It's hard to see that a little bit, but the purple ones are the ones from other countries. So going back to C, let's talk about that. There's little difference between Japanese cars and cars made in other countries. Well, not really, because as I look at this, right, you'll notice that all of these purple dots right here, right, there's definitely a difference between the red trend and the purple trend, right? A lot of them down on this end, on that side. Go to E. Japanese cars tend to get worse gas mileage than other cars. Well, that's untrue because look at the trend. A lot of them are down here, right? But look at where the Japanese cars are. These actually have better gas mileage there. And then look at D. The reason why D is the answer is they are lighter. They are lighter than others. As you look at the weight, the explanatory variable, most of the Japanese cars are on the lighter side compared to the other cars within that same year. Okay. Again, my fault on that. The answer should be D on that. Number 30, if women always married men who were 2 years older than themselves, what would the correlation between the ages of husbands and wife be? Wow, that's a little bit challenging, isn't it? And there's no D answer, I don't think. At least I didn't see that there. Okay, so let's take a look at this one. And in doing this, I'm actually gonna. Okay, let's see here. I want to get rid of that. I'm gonna kind of pull this back up. I want to just show you on a graph, see if we can see this here. All right, perfect. Okay, let's erase this. Okay, so as we look at this, right, we have, I want to make sure I got my explanatory correct. Let me get that exercise back up again. Make sure. Sorry, I'm pulling this up, y'all. Coming. Make sure I got this one. All right, so we've got, I think this is number 30, right? Make sure I got this one. Sorry, I'm trying to pull this up really quick. All right, so if it's true that the males are 2 years older than the females, okay? If women always married men who were 2 years older than themselves, what would the correlation between the ages of husband and wife be? What we're going to focus in on here is, okay, so if it's true that if it's always the fact that the husband's age, and it doesn't really say which one's the explanatory, right? I would say husband's age predicts women's age, because whatever the husband's is, or I guess it could be either way. I could see either way on that, depending on how they ask the question. But what we're saying is that the husband's is always 2 years older. So let's say that we have someone who's 20, right? That means the wife, wow, that's really young. I'm sorry, that was kind of awkward, my fault. This would be 18, right? And it's always the case. If this was 22, what would the woman's be? It would be 20, right? Okay. So it would be 20 and 22. Let's pick one that's much older. So let's say that this is 40 down here. Then it would always be 38. So do you see how the slope would always, it would literally go up by 2 each time. So as this goes right 1, this would go up, or as this goes up 1, this is going to go right 2. Because as the woman's ages increase, the husband's is always 2 greater, right? Okay. So If that's the case, that means that there's going to be a perfect line between the dots or the lines. This one was a little off, but you'll see that there. But do you see how, like, if it's always like 2 greater, this is still a scatter plot. That's true. But now what's going to happen is, because the dots are within the same line and path of each other, if it's always 2 greater, then we can say that that scatter plot has a perfect correlation. And since it has a perfect correlation, we can go back to number 30 and check it out and see that since it's a positive linear relationship, so as the husband's age increases, right, so does the wife's. In fact, as the wife's increase, so does the husband's, however you want to look at that. This should be a perfect linear graph. So that means the correlation, first of all, correlation can't be 2, right? And D's not here. So really the answer would be 1. The perfect correlation would end up being a value of 1 there, okay? So that's why 30 would be B, okay? Because again, it's always, the key word here is always, and so that's what kind of could throw you off on there, okay? All right, the figure below is a scatter plot of reading test scores against IQ test scores for 14 fourth graders. There's one low outlier in the plot. What effects does this low outlier have on the correlation? Well, remember, correlation is it's the relationship between the explanatory and the response, right? It can go from +1 being a perfect linear relationship or association, and it could go all the way to -1, which is a perfect negative relationship. Since this is a positive linear relationship, the question is whether is it moderate? Is it what is it? But the question on this one is, what is the impact that this outlier right here has on the association within here? Now, as I look at this, one of the problems that we can look at is the fact that, if this was, again, perfectly 1, right, it'd be a perfect line, but the 0.9, 0.8, 0.7, those are still a strong linear relationship. May not be perfectly linear, but we're not looking for perfection. We're looking for association. Now, the closer you get to this line, we'll talk about that really more tomorrow, the more you get closer to this line, the better the association. So if they come in closer together, we talked about the fact that the association would be stronger. So the fact that this dot is on the outside, we understand that if we had just dots everywhere, boom, 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 like we call it a cluster, then that relationship is going to be closer to 0. 0 means that we have literally no linear relationship, okay? That's what 0 is. But going from 0 to 1, the closer we get to 1, the larger the positive linear relationship will be. So the fact that the number 1 says it makes the correlation go closer to 1. Well, this outlier does not make it go closer to 1 because it's spread out, right? Now, if this dot is like right here and it was more in the middle, that dot would be true. Okay, it would get closer to 1 because it would follow kind of the natural pattern of this dot plot or this scatter plot. So now B says it makes the correlation closer to 0, but still positive. Sure, it is still positive, okay? But this outlier, that's exactly right, because of the fact, and you'll see the answer here, because the correlation is linear, the fact that you put this on the outside makes it more of a cluster, right? It's not a cluster yet, but it does spread the data out. And so since it spreads it out more, we would say that this would push the correlation closer, the R, closer to 0. But it is still positive. Let's look at C, just show you why these aren't. It makes the correlation equal to 0. That's not true. Correlation equal to 0 is hard because even if I have a scatter plot that goes all the way around here and it's a cluster form, sometimes it might still have a correlation. So no, it's not equal to 0 there. It makes the correlation negative. No, negative correlation would be something that trends downward as the child's IQ test would increase. The child's reading test score would decrease. So that would be negative, and that's not necessarily true. The next one, it has no effect on the correlation. That's not true. An outlier does have an effect on the correlation that's there, okay? And again, that's how you would do number 31, okay? All right, next one. If we leave out the low outlier, the correlation for the remaining 13 points in the preceding figure is closest to what? Well, remember, this does get closer to 0, right? Let's just test this out. First of all, it can't be a negative correlation, right? Because a negative correlation would follow a pattern that would be more in this direction, okay? It would be more negative, right? Be in the negative direction. And it would be a scatter plot, but it would follow a negative slope. So therefore, A and B are thrown out. We already talked about the fact that C is a cluster. So this is not a cluster format here. It does have a positive linear relationship. So we're just gonna just keep that there. So the question is, if we leave out the low outlier, the correlation for the remaining 13 points in the preceding figure is closest to what? Well, this does have a pretty strong linear relationship right here, but I don't think it's quite to the level of 0.95, right? I think we looked at one the other day where, or even today on the podcast, we looked at it and we saw how in a specific situation there were ones like, I think, I'm trying to remember which one it was. I'll have to go look back at the notes that we looked at. But it talked about how 0.97 is still a very, very strong linear relationship. So since it's very strong in that context, we can go ahead and assume that 0.95 would be like very, not perfectly linear, positive linear, but it would be pretty doggone close to perfect. So 0.95 is very, I call, tight together. But 0.5 is still a positive linear relationship, right? It's weak. It's not too strong. It's kind of like moderate. It's like in between. So I would say it's a positive linear relationship, right? And so I would say that 0.5 closely identifies it, even with this outlier being thrown out. Now, if we kept this in, this 0.5 would go closer to 0. Maybe it's 0.36, maybe it's 0.4, but it would definitely have an impact on the correlation that is there, okay? All right, that was a lot of information. Man, we went through a lot there. I know that maybe some of you, hopefully that helps you. Do you have any other questions on any of the stuff that you were looking at? Do you have any questions on any homework problems, anything that's there? I'm gonna look at, this here. I'm gonna look at this. Okay, I did want to, maybe I could just look at this real quick. What did I do really quick today or yesterday? I did want to address. What I'm going to do is I'm going to spot check notes. Is that cool? I think I've already, again, done all this stuff. If you check out the podcast that's due today to watch, that might help you. But I do want to just kind of address a couple of things as we wrap up the next 6 minutes. Again, hopefully the practice of the multiple choice helped you out there. The big thing, correlation, the R there is big time. So as you go through the notes, again, take notes on those and then rock and roll. One thing I did want to address is this DOFs here. Remember that when we have DOFs, we talk about 4 things. We talk about direction, form, and strength and outliers, right? So if I were to talk about this would be a negative relationship. The outliers, you might have one here. So you could say possibly the outlier is at 88% and taking the SAT and related to 460, 470 mean math score. You could say something like that. That would be sufficient for an outlier. As far as the direction, we said it is a negative. It also, for the form, is more of a curved. You see that? It kind of follows a curved pattern, where a linear would more follow something like that, right? Hold up, like this. So this would be a curved pattern. We say moderately because it's not perfect. So a couple things, we say moderate, we could say weak, and we could say strong in terms of strength there. So saying it's moderately strong, linear or curved relationship, and that it's negative. Those are the couple things with DOFs there. Okay, and then putting it in context is huge. So you could talk about, when talking about percent of the individuals taking the SAT, the relationship was that it explained the mean math score, and then go into DOFs of how it explained it and then what the graph looked like, okay? All right, I think we did this one the other day, so we're good there. We went through those notes, the correlation game, we did that. One of the things I did want to address is the idea of R. So this would be my explanatory, this would be my response, right? An R would indicate, of 0, would indicate a relationship where it was just literally a cluster, okay? That's what that would be, literally a whole cluster, no rhyme or reason, right? So there is literally, it has no linear relationship. R of +3, again, this is the E because it's the explanatory, the response would be R. This is positive, right, because it's positive there. But this right here would be like a 0.3 might be something like this, right? Where it does have a relationship, but it's a weak linear relationship, right? So this is the strength, linear is the form, and direction is positive. So this actually does DOFs right here. All of these do DOFs within it. A negative 0.3 would look something like this. Again, it would follow a negative pattern. It would have a negative slope going down for real. And again, that would be more of like a -3R. It does have maybe a little bit of it, but you could definitely see that it is still a weak negative linear relationship, okay? So we're talking, this is all correlation, right? Correlation. Remember, it's between -1 and 1. I think I said that on the notes, -1 being very weak. In fact, this would be, no, I'm sorry, not very weak. This would be like a very negative one. So if I did -1, I'll hop down to this and go back. So if I did -1, again, E is the explanatory. It's always on the X. R is the response. This would actually follow a perfect. We talked about the marriage with females having 2 years less than males' age if it was always the case. This is a perfect, okay, a very strong, and it's actually perfect, negative linear relationship. Okay, that's what that scatter plot is. So very strong. If I did a very positive one, this would follow a perfect, so a very strong positive linear relationship. Okay, so that's the difference that's there. Where I had no relationship, we already talked about, was 0. That's the cluster here. Okay, 0.7 is fairly strong. You could say moderately strong as a perfect one. But it is still a strong positive linear relationship. If I had -0.7, I'd say fairly strong negative linear relationship, right? Okay, so again, this is perfectly negative, and 1 is perfectly positive linear relationship that's there, okay? We went through that in the notes. We went through the calculator. That's perfect. You see this here? This would be a good screenshot to take. This explains the R that's here. You'll see negative 0.99 is not perfectly negative linear, but it is very strong, right? Very strong linear relationship. That's negative, right? Negative linear relationship. Perfect. Okay. I think we are good to go, man. I hope that was helpful for y'all. Look at the podcast. Check it out. Care about y'all. Send me some questions if you need to, either to my phone or email. And I'm going to be on checking them out. I'm grading the projects right now. And all I ask is, and I'll say this again once I post it, please make sure you check. Make sure that when I grade the project and I post those, that I graded them correctly. I grade a lot of them. And so sometimes when I put a note and I say, hey, you didn't have this in there, you actually did. So check it with me and we'll go from there. See y'all. Have a good Cyber Day. Bye. Oh, you know what I need to do? I need to shoot one. Let's see if we can shoot one. I always shoot one. Here we go. Oh, have a good day.